All right, so I think this is recording. Let's take a look at these three problems, and each one they give us two functions, and they ask us to find the composition f composed with g and g composed with f. So here in number one, let's find our composition f composed with g. That is that we're taking g of x and making it the input into the function f. G of x is given as 2x. And this function f, well, what is its job? It always creates an addition problem, and the first term is always the input, no matter what that input is, and the second term is always plus 1. So here they're just giving us, we've got the input 2x, so we have our final answer is 2x plus 1. So this f composed with g of x, we have this new function that we built from f and g, and it is 2x plus 1. All right, so let's move on to the next one. Or no, I'm sorry. It wants us to find g composed with f. So we're still on problem number one. This time f is the input into the function g. F is x plus 1. What does the function g do to the input? Well, g always multiplies two values together. The first one is 2, and the second one is the input, no matter what that input is. So we distribute that 2, and we have a final answer then that g composed with f of x is equal to 2x plus 2. So we used f and g to create these two new functions that were function composition. All right. Let's erase this answer for problem number one and move on to problem number two. The directions are the same, and the idea is the same. So let's come in and find f composed with g. That is, we're taking g and making it the input for f. So in problem 2, this g of x is the opposite of x squared and then plus 5. Well, what does f always do to the input? F always creates an addition problem where it's 2 times the input, no matter what that input is, and then plus 3. So this time the input is negative x squared plus 5. So we have our final answer if we distribute that we have negative 2x squared plus 10 plus 3. 10 plus 3 is 13. So it wants us to find the composition g composed with f. Where this time f is the input into the function g. So for number 2, f is 2x plus 3. G always creates an addition problem where the first term is the opposite of the input squared, and the second term, why we have plus 5. So here we have 2x plus 3 as the input. We're going to square this 2x plus 3, and we get 4x squared plus 12x plus 9. And if you have to, you can make a table and multiply these two binomials in a table. So here we're ready for our final answer that g composed with f of x is the opposite of 4x squared minus 12x, and a negative 9 plus 5 is a negative 4. All right, so let's erase that and do number 3, and then we'll be done with this video. So let's find f composed with g. G is the input into the function f. In problem 3, g is 2x minus 2. Now what will f do to the input? F always creates an addition problem where the first term is the input squared and the second term is plus 1. So if we square this and combine the like term, we'll have our final answer. The f composed with g of x is 4x squared minus 8x plus 5. All right, so let's look at this last part, finding g composed with f. This time f is the input into this function. So what does g do to this input? Well, g always creates a subtraction problem where the first term is 2 times the input, and then it subtracts 2. This time the input is x squared plus 1. So this g composed with f is 2x squared plus 2 minus 2. The 2's cancel, so it's just 2x squared. All right, so ask any questions if needed. I hope this helps. If I've made some type of silly error, then let me know, because it's not too difficult to edit these videos. I will talk to you later. Bye.